When many people hear the word enzyme, they immediately think of the word catalyst. If you didn't, well, now you will. I think of Cupid, who facilitates two people falling in love by shooting one of them in the butt with an arrow, right? And regardless of where the arrow actually hits, Cupid is increasing the rate at which those two people will fall in love. Enzymes increase the rate of reactions. If you were to ingest a hamburger, exposing it to your digestive enzymes, the breakdown of said hamburger or turkey burger or veggie burger, doesn't matter what kind of burger, but the breakdown of said burger would happen much more quickly than if you were to leave it on the countertop to just rot. Actually, there's fungus flying around in the air around you right now, and over time, the hamburger will inevitably get colonized by fungus, which will expose the hamburger and the bread to fungal digestive enzymes and break it down at a rate at which can support the life of the fungus. I have listed here some various enzymes. These are enzymes in your body that can be used over and over and over again. In fact, especially for the top three, your body would prefer to just make them once. Although it doesn't. I mean, enzymes do break down during your lifetime and can be made again, but your body would prefer to never make them and to just use them over and over again. Also, take a look at the structure of these enzymes. These enzymes have very specific protein structure, which means that they're not multitaskers. They don't do a bunch of different things. They do one thing and they do it well. And when they stop doing it, nobody else steps up to do their job. Because enzymes are proteins, they have those very specific shapes from the folding of a protein. One area on an enzyme is called the active site. And this is the place where this is the place where a substance known as the substrate can bind with an enzyme. To understand how enzymes participate in reactions, we should review some terms first. I know this example is silly, but I'm a visual learner, and this is a great visual for understanding how reactions proceed. In any situation with a reaction, we're going to start with things called the reactants or the raw materials. And I'm going to write that, reactants, raw materials. For this example here, the raw materials are these dry frogs. As our reaction proceeds, each frog is going to jump over this barrier and into the water, becoming a product or what is produced. And in this case, our product is the wet frog. Some students reverse reactants and products, but try to think of the word product about what is produced. In math, you have 2 times 2 equals 4, and 4 is the product. In order to get our dry frogs to become wet frogs, there is a barrier to this reaction, and that barrier is called the activation energy. In our picture, the activation energy is the height of the pile of the rocks. The frogs have to jump over each pile of rocks in order to get the reaction started. And this is really important. Enzymes don't contribute energy. They're not capable of doing that. So they're not giving the frogs any additional energy to jump higher. What enzymes do is they lower the activation energy that's required to start the reaction. And therefore, enzymes lower the barrier to the reaction. Think about all of the ways that you can start a fire. Let's do a little analogy here, right? Some of the ways that you can start a fire are really, really easy, like a lighter. And some of the ways that you can start a fire are a bit more difficult, like rubbing 2 sticks together. Your method is your enzyme, right? Your method of using a lighter or a match lowers the amount of energy you have to put in to get a flame. By rubbing two sticks together, you have to put a lot of energy in to get your fire started and get that resulting product of flame.